All right, semester 1 exam, chapter 1 through 7. We're going to work out today 1 through 28. That's the first 4 pages. The graduated cylinder shown below contains 500 grams of a liquid. What is the density? So the first thing I'm going to say to myself is density is mass divided by volume. Now, they tell me that the mass is 500 grams, so I already know that. Now, for the volume, it's not given. What I need to do is I need to read the graduated cylinder. So when I read the graduated cylinder, this is 250 milliliters. So 500 divided by 250 is 2, so it's 2 grams per milliliter. So it's choice B. Number 2. The diagram below represents a rectangular object with a mass of 450 grams. What is the density of the object? So first of all, for number 2, I know density is mass divided by volume. They tell me the mass is 450 grams, but they don't tell me the volume. But I see the picture. Now I can calculate the volume. It's equal to length times width times height. So 15 times 5 times 2 is equal to 150. A centimeter times a centimeter times a centimeter is a centimeter cubed, over 150 centimeters cubed. So 450 divided by 15 is 3. Now what I did on this test this year was to eliminate people having text anxiety, because that happens sometimes. People get nervous when they take a big test. I deliberately put these really, really easy answers on the first part of the test, and then after that we have the test in reverse order for the one we just had a test on. Okay, so the answer here is C. Which line segment has a length of 3 centimeters? Now the reason that this is on the test is because we've been doing labs all year long. Almost every lab that we've done, you've used a meter stick. So you should have a relative idea of how big a centimeter is. So this says, what is the length of 3 centimeters? Now I'll show you the ruler, but you should have a relative idea here that, so the answer is 3 centimeters. So you should maybe have a way where you know, like your small pinky is a little bit more than a centimeter, or maybe your thumb is 2 centimeters, but you should have a relative idea. We know how big a meter stick is, which is 100 centimeters, but you should have a relative idea, approximation, of how large metric units are that we've been using all year long consistently in this class. So this was B, C, and B. Okay, number 4. It says a piece of copper metal is correctly placed on a triple beam balance. The riders are all at the 0 mark. So we've used triple beam balances throughout the year when we do labs, so we know how to properly read the instrument. When we read any instrument, the way to read it properly is you read to the smallest division, which are those teeny lines, and then you approximate between the lines. So we want to find the mass. So when I look at this, it says 5.5. But then, because it's right on the line, that means we're going to say 0. So the correct answer is 5.50. If it was in between, then it would be like 5.55. This one's kind of difficult to read, especially when it's tiny. So the answer here was B. It says the diagram below shows 3 graduated cylinders. The contents of cylinders X and Y are poured into cylinder Z. Which letter represents the amount of liquid that will be in container Z? So all I'm doing is adding them together. So this one, this is, do I know how to read a graduated cylinder? So this is 250. This one is 100. So this is going to be 350 milliliters. So I don't know if you can see the letters are here on the side, so 350 would be choice C. So again, this is just testing you. Do you know how to use the instruments that we use in the lab all the time? Number 6. A centimeter is 0.0 meters. This measurement can also be expressed as, now you could do this on your calculator. So I'm going to show you on the calculator. Now you should know how to do this in your head, but if I press 0.01 and then I press second and then I press SCI, which is behind the 5, see how it automatically puts it in scientific notation for me? Okay, so this is really a question. Do you know how to use your calculator? The one we're going to be using on the test. The next question says, so that was B. The diameter through the equator of Jupiter is about, and it's a huge number. What is this distance written as a power of 10? So what I do when I do this is I take my decimal point and I move it over 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 1.43 times 10 to the 9th power, which would be choice A. Number 8, when measuring the distance between Atlanta to New York City, which would the best unit of measurement be? Well, a millimeter, those are these little teeny weeny lines. A centimeter, those are this 1, 2, 3, 4, 5, 6, 7, 8. A meter is like a meter stick, so the largest unit is the kilometer. So that would be the most appropriate. Now, if you look at, I was explaining that, and it took us about 6 minutes. On the test, these problems you can do in a lot less than 6 minutes. Okay? The same types. Are they going to be exact? No. Okay, number 9. The graph below shows the world population. So this has to do with, do you know how to read a graph? We do a lot with graphs. We draw graphs in this class. We interpret graphs in this class. So this just has to do with basic graphing knowledge. The graph below shows world population beginning in the year 1800 and projected to the year 2000. The graph shows the greatest increase. So the greatest increase is going to be the steepest slope. And we're going to see that, remember here you can do little pretend tangent lines to help you. So the steepest slope is obviously going to be between 1975 and 2000. Number 10. The graph below shows the temperature readings for a day in April. Okay? What is the average rate of temperature change in Fahrenheit degrees between 6 a.m. noon? So what I'm going to do is I'm going to highlight here's 6 a.m. and noon, here's noon. So at 6 a.m. it was 30 degrees. And at 12 noon, it was 48 degrees. So that's an 18-degree difference in 6 hours. So 18 degrees over 6 hours. So 18 divided by 6 is 3 degrees per hour. So that's choice C. All right, let's flip over to page 3. Okay, now we're doing what we're doing now, which is this is conservation of energy. So it says base answers to questions 11 to 13 on the diagram below, which represents an object M suspended by a string from point P. When object M is swung at a height of h and released, it passes to the rest position at a speed of 10 meters per second. The height h from which the object will release is approximately. So we know we're going to do conservation of energy. So the total energy here, this is my initial, is equal to the total energy here final. Okay? So the total energy here, is it moving? No. So if I say it's the potential I plus the kinetic I is equal to the potential F plus the kinetic F. Here, I, there's no kinetic, so that's 0, so this is mgh. And down here, this is our frame of reference, which is the ground, which is base level. So here, the potential energy is 0. So mgh is equal to 1/2 mv squared, 1/2 mvf squared. So my masses cancel, and I guess I should have done this one on a piece of paper. And then I'm going to rearrange the equation to solve for the unknown in terms of the known, and I'm going to solve for, oh, you don't even have to, this one, it tells you the speed here is 10 meters per second. Oh, so we're finding the height. So we're going to rearrange the equation. So we had, if I cancel the m's, mgh is equal to 1/2 mv squared. So if I cancel these, I have gh is equal to 1/2 v squared. So h is equal to 1/2 v squared over g. So it's 1/2 of 10 squared divided by g. So 10 squared is 100, divided by 2 is 50. 50 divided by 9.8, I can do that on my calculator. Or I can just approximate, instead of 9.8, 10. And if I approximated 10, I would get 5. So I could just do 1/2 10 squared over 10. Number 12, the centripetal force on object M as it passes through the rest position is, so the centripetal force is equal to Sd, and we know that the centripetal force would then be equal to 10 newtons, and then it says the centripetal force on the object could be half. So when you're talking about centripetal force, always write down your equation. F of c is equal to mv squared over r. So it says if this was half, don't do this in your head, if this was half, what now is going to happen to, what would I have to double for this to be half? So you have to look at the equation. For this to be half, what would have to be doubled here? If I doubled something in the numerator, if I doubled m or v, is this going to be half? No. What I would have to do is I would have to double r. So if this was double, that would be half. So I would write the equation down. I would look at it. So r would be the length of the string as it goes by. So this is B. Okay, let's look at this one. I think I need to have some paper out so I can work these out. And I want to go through 20-something. Okay, so here's the one. In the position shown, the object's centripetal acceleration. So remember, there's two things you have to remember. The centripetal acceleration is always pointed towards the center of the circle. And you also know that the velocity is always going to be tangent. So you have your velocity and your acceleration. So in the position shown, the object's centripetal acceleration is directed towards point D, which is the center. This is actually up a little bit, so it's this way. That's the center, which is D. So the acceleration is always towards the center. The force is always towards the center, and the velocity is always perpendicular to the. And the other thing about the velocity, you see how it's going in this direction? That's how I know it's pointing this way and not up. So that's another mistake you can make. In the position shown, the object's velocity is directed towards point, so we know that one's A, and that's why it's not B. It has to go in the same direction. The centripetal acceleration. So how do I find the centripetal acceleration? I know F of c is equal to MAC. So AC is equal to the F over M. So it's equal to, what is F in this problem? Here it is. 4 times 10 to the 2 divided by M, which is here it is, 5. It's in the problem. So now I'm going to take my calculator, and I'm going to say 4EE2 divided by 5 equals, and it comes out to be 80. Oops. So that's going to be 80 meters per second. That's choice C. The object's speed, so again, centripetal force is equal to mv squared over r. I just found, so now I'm going to rearrange the equation to solve for v. So v is equal to the square root of fr over m. I'm kind of skipping the intermediate algebra steps because in the last chapter I did that like so many times. I'm just trying to get this done. So then we substitute in our values, and f is equal to 4 times 10 to the 2 times r, which is 20, divided by m, which is 5. So 4EE2 times 20 equals, divided by 5 equals, and square root, and I end up with 40. So this is B. Number 18, if the radius of the track is increased, the centripetal force necessary to keep the object revolving at the same speed was. So you don't do this in your head. You write down the equation. Centripetal force is equal to mv squared over r. So it says if the radius is increased, so if this here gets larger, what happens to this? Well, they're inversely proportional, so this is going to get smaller, so it's going to decrease. That's how you do these problems. You write the equation and you look at it. You don't try and figure it out in your head. There's nothing to memorize. You don't memorize. Memorizing is an understanding. Number 19, planets move around the sun in what type of orbits? They're elliptical. That's Kepler's first law. And we have one more page to do. Okay, number 20. So number 20 says, this is also on Kepler's law. According to Kepler's second law, a planet must move fastest when it is closest to the sun. Because remember, having to do with conservation of energy, when it's closest to the sun, it has more kinetic energy and less potential. When it's farther from the sun, it has more potential and less kinetic. So this answers A. Number 21, as the mass of a body increases, the gravitational force of attraction. So what I'm going to do is I'm going to write down the equation. F of g is equal to big G, m1, m2 over r squared. So it says as the mass increases, what happens to the gravitational force? So as this gets bigger, what happens to this? It also gets bigger because they're directly proportional. So that's going to increase. Number 22, the centers of two 15-gram spheres are separated by 3 meters, the magnitude of the gravitational force. So the equation for number 3 is F of g is equal to big G, m1, m2 over r squared. So it's equal to 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared times 15 times 15 divided by 3 meters squared. So I put that in my calculator. I would just say 15 squared times 6.67 EE minus 11 equals divided by 9 equals. And then it's some long number, so I'm going to put it in scientific notation. So it says 1.67 times 10 to the negative 9, which is going to be answer C. Number 23. A motorcycle travels around a flat circular track. If the speed of the motorcycle increased, the force required to keep it in the same circular track. So F of C is equal to mv squared over r. So if V increases, what happens to this? It's also going to increase, right? So as this gets bigger, this gets bigger. So that's going to increase B. Number 24. It says, if object O is moving in a uniform circular motion around point P at a constant speed, which vector shows the centripetal force? So there's one thing you need to know. When something's going in a circle, the centripetal force is always going to act towards the center. So the one that's acting towards the center is only this one. So that's going to be choice B. All right. So this was from the last chapter, so this is fresh in our head, right? Number 25, the diagram below shows the movement of a planet around the sun. So area 1 equals area 2. Compared to the time it takes, so Kepler's law says equal areas in equal time. And the reason this time is equal to this time is because that here it's moving faster and here it's moving slower. Remember when we talked about conservation of energy? We talked about when the Earth is closer to the sun, it moves faster, the kinetic energy is greater, and the potential energy is less. And then over here, the potential energy is greater and the kinetic energy is less. So the answer is, so it says compared to the time, we know that the times are the same. Equal areas and equal times. All right, so these questions all have to do with this one picture. So it says base your answers to 26 through 29 on the diagram which represents a car of mass. So the mass is 1,000 kilograms, traveling around a circular track. The radius is 200. So if I want, on my scrap paper, I might want to write this. I want to write mass is 1,000. I might want to say radius is 200, and the speed is 20 meters per second. So now I have all my givens. So number 26 says when the car is in the position as shown, the direction of the centripetal acceleration. So the centripetal acceleration always acts towards the center. So the answer is C. The magnitude of centripetal force is number 27. So I'm going to write my equation. Centripetal force is equal to mv squared over r. So it's going to be 1,000 is my mass times v, 20 squared over r, which is 200, because that's my stuff here. So now I'll take my calculator, and I'll say 20 squared times 1,000 divided by 200 comes out to be 2,000. So that's C. Remember, you were supposed to do this last night for homework, remember? I'm just going over the answers. Your homework was to do the first third of the worksheet. Number 28. If additional passengers were riding in the car at the original speed, the car's centripetal acceleration would be the same. How do I know that? Am I just guessing? Am I memorizing an answer? No. They said if additional passengers, they're asking me about the acceleration. What do I know about acceleration? Whenever they ask me a question, it's asking me about the centripetal acceleration. The first thing I'm going to do is I'm going to write the equation. Centripetal acceleration is v squared over r. So now I'm adding mass. Is mass in this equation? The only thing that affects the centripetal acceleration is going to be the velocity and the radius. Are those changing? Just the mass. Now the mass affects the centripetal force, but not the centripetal acceleration. Okay? So that's why the answer is the same. We don't guess on these. We don't make it up. We don't memorize that answer. You see, when they ask you a question about centripetal acceleration, if you write the equation, you can clearly see in the equation that it's independent of mass. That's how you do these questions. And that is 1 through 28. And that's it.